Hi everyone! If you watched the previous videos, by now you know how to build charts in SPSS and also how to check assumptions of parametric tests or parametric data. Today we are going to do correlation. Correlation actually measures the relationship between two variables. For example, the more you practice SPSS, the easier it gets. There are three possible relationships between the two variables. They can be either positively related, meaning that the more you practice doing SPSS, the better you become. They can be not related at all, meaning that as you practice doing SPSS, your ability remains completely constant, so nothing changes. Or they can be negatively related, which would mean that the more you practice doing SPSS, the worse you get, which is very unlikely. So, to express the relationships between variables, statistically, we can look at two measures. First, we will look at covariance and then at correlation coefficient. So, what is covariance? To look at whether two variables are associated is to look at whether they covary. To understand covariations, first we have to remember what variation is or variance is. Remember from the homogeneity of variance video. So variance of a single variable represents the average amount that the data vary from the mean. So if we are interested whether two variables are related, then we are interested in whether changes in one variable are met with similar changes in the other variable. Therefore, when one variable deviates from its mean, we would expect that the other variable to deviate from its mean in a similar way. To give you an example, we will look at the following table, and again this is based on Andy Field's book Discovering Statistics Using SPSS. So imagine that we took 5 people and subjected them to a certain number of advertisements promoting sweets. And then we measured how many packets of those sweets each person bought during the next week. So in this table you can see the 5 participants. Here you can see the number of adverts they watched, and here you can see the packets of sweets they bought after they watched these advertisements. Here are the means and here are the standard deviations. In the following figure, you can see these data visualized. So what do we see here? Here you can see the number of packets of sweets they bought after watching the advertisements. This line is the mean packets of sweets, and this is each data of participants. Here you can see the mean adverts they watched, and here is each data of participants, and this is the difference from the mean, so the variation actually. So how can we calculate the similarity between these two variables? What we can see already is that there is a similar pattern in each variable. The first 3 are under the mean or below the mean, and the second 2 are above the mean. You can also see that there are negative values here, so to rule out negative values, what we can do is we can multiply them with the corresponding value in the other variable. So how do we calculate the covariance? We multiply the corresponding values in the two variables. So if we go back, we multiply -3 with -0.3, -2 with -1.4, and we add them up. The result is 17, and this 17 should be divided by the number of observations, which is 1, 2, 3, 4, 5 minus 1. That will be 4, so 17 divided by 4. Our covariance is 4.25. The problem with this number or this value is that it is dependent upon the scale of measurement, because for example if our scale is kilometers, then converting it to miles would change the covariance. So we need something more reliable. We need to standardize this measure, and for that we used the standard deviation. So you can see that we put into the table the standard deviations, which is 1.67 and 2.92. So what we do is we multiply the two standard deviations with each other, which is 4.88. Then the correlational coefficient will be covariance divided by the multiplication of the standard deviations. Okay, so this number will be divided by the multiplication of the standard deviation. So the coefficient, Pearson correlation coefficient, will be 0.87. We never indicate the 0 here because the correlation coefficient can go from -1 to +1. Correlation also has effect size, and this is constant, so you can use it when interpreting your results. Plus or minus 0.1 represents a small effect, so the correlation is not very strong. Plus minus 0.3 is a medium effect, and plus minus 0.5 is a large effect. Before we do any statistics, it is very important to remember whenever you do any correlational study that correlation is not causality. So in our previous example, the number of advertisements didn't cause people to buy sweets. These data are associated, they go together. There was a positive correlation between the two, but it wasn't caused. At least for two reasons. The third variable problem. In any correlation, causality between two variables cannot be assumed because there may be other measured or unmeasured variables affecting the results. For example, seeing other people eating sweets can also influence our habits of buying sweets. And the direction of causality, correlation coefficients say nothing about which variable causes the other to change. So correlation cannot be interpreted as causality. There are two types of correlation. Bivariate correlation is a correlation between two variables, and partial correlation looks at the relationship between two variables by controlling the effect of one or more additional variables. Bivariate correlation can be Pearson, Spearman, and Kendall. And now we will do this in SPSS.